these two that can be taken common. Nothing is common then. So 16 by the project 16 this. If I take square root 16 y raised power 2 by 3 common. 16 by raised power 2 by 3 will be the bracket x square. Okay, minus sign I cannot be minus sign. Equal sign only. So this is plus 16 is taken, y raised power 2 by 3, but take common, it will be 6 by 3, that means 2 only. 8 by 3 minus 2 by 3, that means 8 minus 6 is 6, 8 minus 2 is 6, 6 by 3 is y square. Okay, then plus a, if I take common, it will be a raised power 4 by 3 common. Within bracket PR, we have 4 by 3, 4 by 3, 4 by 3 only. This is with minus sign 8 into y raised power 4 by 3. Anything y raised power 2 by 3 in this value. If I substitute the value of y raised power 2 by 3 common, y raised power is 4 by 3. This is 2 by 3. If I substitute that value, value of 2 by 3 is here, that value is there. So that can give us something. Let me substitute that value. And then in the denominator we have got 4 into x y raised power 1.3. Okay, so let me further substitute the value. What value substitute? Either substitute the value of x, this one, or value of y raised power 2 by 3. Where y raised power 2 by 3, it means this whole upon this value. That can give us, okay, if I substitute the value of x square plus y square, this value, that can give us that value. Okay, so let me resolve it further. So if I substitute, because it can be in x and y problem, let me substitute value of x square plus y square from this equation. X square y square 4x y square is equal to a square plus divided by 4. Even if it is 4, okay, no problem. Let me substitute this value from first equation and this let me take this second equation. So from first and second, what do we get? From first and second we get here. Now this 1.4x by raised power 1.3 is out of this square root. That are taken, this one are taken out of bracket, out of this. Okay, so now this is 16 y raised power 2 by 3 into, if I substitute value of x square plus y square, which is this, first take for this a square to that side, that means 3 a raised power 4 by 3 into y raised power 2 by 3 plus a square upon 4. Okay, plus under square root is a raised power 4 by 3 into a raised power 4 by 3 minus 8 y raised power 4 by 3 only. So this 4 for the 16, 4 cancelled out. So multiply this 4 can give us something. So let me check whether something is cancelled out. So this will give us on the root, multiply by 4 by 2 raised power 2 by 3, so this 4 here 12, with 12 a raised power 4 by 3, first one, into y raised power 4 by 3 into y raised power 4 by 3. Okay, because y raised power 2 by 3 plus 2 by 3, 4 by 3. First step. Second step will be 4 into a square, this one, into y raised power 2 by 3. Y raised power 2 by 3. Okay, this a square into 4 y raised power 2 by 3. 4 a square into y raised power 2 by 3. Okay, plus this whole value. If I okay, multiply them, it will be 4, sorry, a raised power 8 by 3 minus sign 8 into a raised power 4 by 3 into y raised power 4 by 3 This one step, 12 by a raised to 4 by 3 by raised to 2 by 3 are common. That can be cancelled out. Let me take common and subtract them. So it will give us something. What is that? This is 8, this is 12. So only 4, okay, and 4 can be taken common. All right. That will be in the root. We will add here 4x by raised to power 1.3 in the denominator. It's already there. So this is 12 and 8 means 12, sorry, 4. A raised to power 4 by 3. Y raised to power 4 by 3. Same like term. This is like term. 12 A raised to power 4 by 3, Y raised to power 4 by 3, and this is 8 A raised to power 4 by 3, Y raised to power 4 by 3. They are similar terms or like terms. We have subtracted 8 from 12, so this is 4 only. Plus 4 A square Y raised to power 2 by 3. Y raised to power 2 by 3 can be taken out. That will be 1 by 3 will come out. Okay. Y raised to power 4 by 3 and this is 2 by 3. If I take out, then square root will be taken. Square root will be 1.3. Y raised to 1.3 will be out. 4. 4 means 2. So 4 and y raised to power 2 by 3 can be taken out. That will give us 2 into y raised to power 1.3 we have taken out. So y raised to power 2 by 3, y raised to power 2 by 3, and a square also can be taken. If I take a also, let me write here. This is a 2a 4 minus 3. This is negative, no problem. It will be a into y raised to power 1.3 we have taken common, divided by 4x y raised to power 1 by 3 cancelled out. Under the rule, what is left? 4 we have taken out. Now a2, that means a raised to power here 4 by 3 minus 2 we have taken common. Okay, so 2 if I have taken common, so this will be minus 2 by 3. A raised to power minus 2 by 3 only left. And y raised to power 2, if I take 2 by 3 common, 2 by 3 only left over. Okay, and this is plus 1 only. This whole value we have taken common. What we have taken 4a square by this one taken common. This will give us, okay, now it is looking like a question, but it is now easier one. This will give us, okay, a is there, y cancel out. So this is a upon 2x, a upon 2x. Okay, under the square root, because 2 to the 4, so 2x only by q by 1.3 cancelled out. And this is y raised to power 2 by 3 upon a raised to power 2 by 3. That means if I take a raised to power 2 by 3 common, and I mean LCM, then it will be a raised to power 2 by 3. A raised to power 1 by 3 will be out. Its final answer is, let me write it as, for square root will be 1.2 and 1.3 cancel out. A 1 minus 1.3 upon 2x under square root. This is a raised to power 2 by 3. This y raised to power 2 by 3 can be taken common. Only this value is left over. This is a raised to power 2 by 3. 3 minus 1, 2 by 3. A raised to power 2 by 3 out, divided by twice x. Under square root, a raised to power 2 by 3, y raised to power 2 by 3. Okay. This is the answer. This looks like answer. Okay, no problem. Simpler one. This is the value of question number 4. So question number 4 is done. Okay. Up to 4th we have done. Now question number 5th one. What does it say? Let me solve question number 5th. Now question 5th says that, okay, what the question number 5th say? Let me solve it further. So question number 5th says, we solve the exercise further. So this question says that for the parabola y square equal to this, y square equal to 4ax, first equation proves that, okay, prove what we have to prove, that ds upon dx equal to under root a plus x upon x. Okay, that let me solve. मतलब parabola y is equal to 4ax. Okay, for equation y equal to 4ax. Prove that dx upon dx equal to under root this. Let me find out differentiation of this. So dx upon dx for dx upon dx under root 1 plus dy upon dx whole square, that is to be equal to dy dx. Let us find out. Differentiating first with respect to x, we get d 2y into dy dx is equal to 2y dy dx will give us 4a only, because x is one differentiation. This means 2 dy dx is 4a upon 2y, that means 2a upon y only. Okay, therefore we know that ds upon dx is equal to this Cartesian formula for derivative of a curve or derivative of an arc. Arc derivation is 1 plus dy upon dx whole square. ds upon dx is 1 plus dy upon dx. If it is denominator dx, then it is dy upon dx. But it is dy, ds upon dy, it will be 1 plus dx upon dy. Okay, so it depends on the denominator. Now dy dx is this value, which is dy dx is 2a upon y, so substituting this value. So from this second equation, first and second, now let me write here from first and second, or substituting value from second in this. Okay, not from first and second. It should be a substituting value from second. So this is 1 plus dy dx is this value from second. This is 2a upon y whole square. This is from second. Okay. Now squaring this, so we get 1 plus 4a square upon y square. If I substitute value of y square, which is 4ax, in the denominator, we can solve it, and it will give us 1 plus 4a square upon y square. Y square is 4ax. This is 4ax. This is from first. Just write first. From first, we have substitute the value of y square. Y square is 4ax. 4a square upon 4ax. 4 cancel out, 1a cancel out. Okay, so a upon x, that means under root 1 plus a upon x is left over. Now taking LCM, x will give us x plus a upon x only. This is a plus x upon. Okay, this is, or a right first, then x upon x, which is solved. This is the same answer, hence proved. This we have proved. A plus x upon undo a plus x upon x. Okay, so that is the question number 5 we have solved. Now let me take the 6th question. Now question number 6 says, what the question number 6 says? I'm sorry. Now question number 6 says, that is follow no problem. Now let me take the question number 6 here. The question number 6 says, that, okay, so let me note it up here. Now, the 6th question says that, okay, what is 6th question? Prove that for ellipse x square upon a square plus y square upon b square equal to 1 for this ellipse. Okay, if x equal to whether a cos phi, okay, then prove that then ds upon d phi is equal to a into under root 1 minus e square into cos square phi. Okay, this we have to prove. Alright. So this is ds upon d phi. no problem. So first of all, we have to find out what is this whole equation in terms of phi only. If I substitute the value of x there, y can also be then find out. So then ds upon d phi we can solve. Ds upon d phi will be then this equation. So let me solve it. So okay, we are given x equal to a into cos phi. Okay, if I substitute the value, okay, this x here, we will get y square equal to what? So if I substitute a, that means a square into cos square phi. In place of x, if I substitute this value upon a square, this is cos square phi, a square cancelled out, plus y square upon b square equal to 1. That means a square cancelled out, so y square upon b square equal to cos square, 1 minus cos square, sorry. This is 1 minus cos square phi, that means sin square phi. Y square equal to b into b square sin square phi. Y is equal to what? This is this value, that means b into sin phi. So y is okay this value. So let me, this is just like ds upon d phi, that will be equal to dx upon d phi square plus dy upon d phi square. Okay, if I substitute that value here inside the square, so ds upon d phi, for that we have to find out what is dy upon d phi and ds upon d phi, just like theta, ds upon d theta and d upon, okay, or sorry, dx upon d theta, dy upon d theta. Similarly, we have to find out this value. So therefore, ds upon, first find out dx upon d phi. So from this one, this is second was given to us, this is third one we have obtained. So from third one, dx upon d phi differentiating second and the third with respect to phi, we get dx upon d phi, this is equal to minus a sin phi, for cos phi is minus sin phi, and dy upon d phi, this one give us b cos phi, this is positive, b cos phi. If I substitute these values, okay, inside the this value of ds upon d phi, therefore ds upon d phi can be given as, therefore ds upon d phi we have to find out, which is nothing but like dx upon d phi whole square plus ds upon d phi, sorry, dy upon d phi, this is dy upon d phi whole square. If I substitute these values, in this case it will give us dx d phi is minus a sin square, this is a square sin square phi, okay, plus b square cos square phi, because the whole square of this d square by upon dy upon dx whole square means b square cos square phi, and dx upon d phi whole square means a square sin square phi. Now we have to know that in case of ellipse, what do we have? In case of ellipse, we have written that here. In case of ellipse, what is the value of b? B square is given as a square into 1 minus e square. Sorry, this is 1 minus e square. So value of b square, which is below y square, this b square. This is essentially e here. So in case of conic section, we have described this in detail in geometry, coordinate geometry. In coordinate geometry, there is one section, conic section, in which we discuss about parabola, ellipse, and hyperbola. In case of ellipse, we have b square equal to a square into 1 minus e square. If I substitute here b square, it will give us a square sin square phi as it is, plus b square in place of b square, a square into 1 minus e square into sin cos square phi. So substituting this value of b, this is square root, we get cos square phi. This is into cos square phi under the square root. Okay, so this is b value of b square. In case of conic section, we know. In case of ellipse, it is b square equal to a square into 1 minus e square. In case of hyperbola, it is b square equal to a square into e square minus 1. So in that case, e is greater than 1. But in case of ellipse, it is less than 1. So e square 1 minus e square. Okay. So let me solve it further. This is now a square is common. A will out, a will be out. Some sin square phi is left over. Here it is 1, cos square phi minus sin a we have taken, and this is cos square phi into 1, that means cos square phi e square into cos square phi, and leave a we have taken out of the square root, so it will a only, a square common. Okay, so this is 1 sin square phi plus cos square phi. So under the square root 1 minus e square into cos square phi. Is it the same answer? Okay, it is the same answer. It is a under root 1 minus e square cos square phi. This is the proof. This is proof. This is the proof which we wanted. So this is how we have to solve it. Okay, so in case of b square, we have substituted value of b in terms of eccentricity in case of ellipse. Okay, so that is the only logic here. Now let me take next question. What does the next question say? So question number 7 says, okay, what is the question 7? It says that calculate ds upon dt for the following curves. Okay, this is in parametric form. Let me solve it. Question number 7 here. It says calculate ds upon dt is to be calculated. So just like ds upon, if it is other parameter like phi we have calculated, so we know that ds upon dt is under root dx upon dt whole square plus dy upon dt whole square. That is a parameter form. So ds upon dt is to be calculated like that. So in this case, what the a part says? Seventh question, a part is x equal to t square and y is equal to t minus 1. Okay, so find out what is ds upon dt. Differentiating these with respect to t. Differentiating these means this first one and second one, x and y values. Okay, these with respect to t, we get this is dx upon dt. Will give us twice t, because differentiation of t square is twice t. Okay, and differentiation of t and dy upon dt, and dy upon dt in this case is 1 only, because t is 1 and minus 1 is 0. So this is dy dt. Therefore, ds dt will be equal to under root dx upon dt whole square plus dy upon dt whole square. That will give us, let me substitute the values here, is twice t whole square plus 1 square, because dy dt is 1. It is nothing but 1 plus 4t square. This is 1 square is 1 and 2t square is 4t square. This is the answer, dx upon dt. That's what dx upon dt. First dx upon dt of first question is this. Here this is the answer. Now let me take next question. Second part of this is question 7th here. Let me take 7th question, part B. Okay, so part B says that x equal to, we have to find out ds upon dt in this case also. So x is, in case of second part, a secant t, and the y is what? B tan t, b into tangent of t. Okay, so b is tan t. Okay, secant t and b tan t. So let me take first and second. Differentiating these first and second with respect to t. With respect to t here, we get, I mean in this case, with respect, because t is the parameter, so we have to differentiate all these with respect to t. That is no doubt about this. So then dx upon dt in this case is a secant t is secant t into tangent t, because secant t is differentiated secant t into t. Okay, and dy upon dt, second one is dy upon dt is b into nt is secant square t. Okay, so therefore ds upon dt, which is equal to 1 plus ds upon dt whole square plus dy upon dt whole square. Substituting these values here, okay, of ds upon dt and dy upon dt in this equation, it will give us, this is a square ds upon dt whole square, that is this a secant square t tangent square t tan square t plus dy dt whole square is b square into sec square t is already there, so it will be sec 4 t sec 4 power t, sec is power 4. Now what is common here? A and b cannot be taken common. Only sec square t is common. Let me take secant t out of square root, because sec square t in the square root and sec t out of that, so it will give us a square into tan square t plus b square into secant square t only left over. Okay, now secant square t, any value of this, nothing, only in terms of t, we have to find out the answer. If I take secant t in case of value of secant square t as 1 upon t, I mean in terms of tan t, then it can be further resolved a square tan square t. Okay, tan square t plus b square into sec square t is 1 plus tan square theta. That means 1 plus tan square t. So we have substituted the value of sec square t, that is 1 plus tan square t. After substitution of this value, we have obtained ds upon dt dash. Let me write it here. So therefore, ds upon dt we are calculating is equal to, here it is secant t, I'm sorry, this is secant t out of the square root. Under the square root we have a square into tan square t, a square into tan square t plus b square as it is plus b square tan square t. What is common? Secant t, which is out of the square root. Here it is tan square t common. If I take tan square t common, it will be a square plus b square plus b square only. Now it cannot be further resolved. Okay, so we cannot solve it further. Only this is the answer. Either b square plus a square b square into tan square t is the answer. No further resolution of this. So this is the final answer. Okay, because nothing is to be calculated. I mean ds upon dt must be in terms of t only. Tan t and this second t. The answer is final. The final answer is this B part. Now let me take what is the C part. Now in case of C part, what we have? Okay, question number 7 here we are doing. Okay, so question, this C part here. C part is, question 7, C part is x equal to a into cos of t plus t sin t, t sin t. Okay, this is a into cos t plus t sin t, comma y is, what is that? A into sin t minus t cos t. This is the value of y. Okay, y is a sin t, t cos t. All right. Now solving them, this is first equation. This is the second one. Finding out differentiation. Differentiating them, first and second, with respect to t, we get, this is dx upon dt is equal to, differentiation of this is, what is differentiation? If constant as it is, it will be minus sin t of cos t differential is minus sin t. Plus now this is t sin k. It is in product rule. T as it is, cos t differentiation is, sorry, sin t differentiation is cos t plus t differentiated as 1, sin t only. Okay, so t is 1 and sin t as it is. So sin t and sin t cancel out. It is nothing but a into t into cos t. Dx upon dt is at cos t. Sin t cancelled out. While because it was minus cos t, t sin t is differentiated in product rule. So t as it is, sin t is cos t plus sin t as it is, t differentiated as 1 because we are differentiating with respect to t. Okay, therefore, and d by dt, second part, this one, is a as it is, what is sin t? Sin t difference is cos t minus again by product rule. T as it is, cos t is minus sin t. This will be plus sin t, so t into sin t. Now it is minus sin. Cos t as it is, t is 1, differentiation. If cos t cancel out. It is nothing but a into t into sin t. This is d by dt, very good. Okay, so this is excellent one. So at sin t and this is at cos t. Wonderful. Now, what is the formula answer? So therefore, dx upon dt is given by dx upon dt whole square plus this is dy upon dt whole square. Substituting the values of dx dt and dy dt, which we have just calculated, dx dt is this 80 times cos t. This is a square into t square into cos square t plus dy dt is this 80 sin t, that means a square t square into sin square t. Nothing, this is a square t square we can take out, at will come out, it is cos square t left over plus sin square t left over, and that is 1, only at is the answer, 80 into 1 is equal to 80. But so under the square root it says sin square theta plus cos theta is 1. That is 1, square root of 1 is 1, 80 only. 80 is the answer. So ds upon dt in this case is 80 only. Okay, so C part is done. So let me the D part. Let me take the D part. What does the D part say? Let me check it. This question is given. What kind of question is given? Okay. So D part here is, sorry, this one. Here D part says